সোমবার হয়তো করবে, এখন দেখো ওটা ডেট দেবে। আর আরেকটা জিনিস আমি তোমাকে বলে রাখি, শোনো আগে আমার কথা শুনুন।
Am I audible?
Yes, sir.
Okay.
Good
Wait for
afternoon,
2 minutes.
sir.
Good afternoon. Very good afternoon. Let us wait for two minutes so that the rest
afternoon,
of the
sir.
students. Good afternoon. Let us wait for 2 minutes so that others could join, and then we will start the class. Thank you.
रुको ना, थोड़ा सा चुप रहो।
Okay, let us start the class without further delay because we have already delayed for 2 minutes, 2 to 3 minutes. So the rest of the people will join, I think. I don't know why they are not joining till now. So let us start the class. Okay, so let us start the class. I think everybody can watch the whiteboard. So today we will discuss, last day we have started with the transistor and we have discussed about those transistor symbols and etc. other things of a transistor, introduction to transistor, what is this, why it is called transistor, what are the regions of transistor, etc. So today we will discuss about the basics of transistor, biasing, and then we will talk about the configurations of different types of biasing of a transistor. Okay, so let us start with the first procedure. Okay, just a minute.
आपका आवाज नहीं आ रहा।
Hello.
Yes, sir.
Now it is audible.
Yes, sir.
Okay. So we will describe briefly about these four modes of operation of transistors by using the circuit diagram, and you will learn why it is called active, why it is called saturation, why this is called cutoff region, and why it is called inverted region. So let us start with this. So our first case was case number 1. That is active region. So if I draw the circuit diagram, we are taking here for our well operations, we are taking here NPN transistor for each cases, okay? So for the active region, the emitter base junction is in forward bias and the collector to base junction is in reverse biased. So I am connecting the DC supply in forward bias. And I am connecting the common base or base and collector junction in reverse bias. So this is a NPN transistor. This is plus, this is minus, this is VEB, and this is minus, this is plus, this is VCB. So this is the base, this is the emitter, and this is the collector. In this mode, the emitter base junction is forward biased and the collector base junction is in reverse biased. Battery VEB is the connection between the emitter and base so as to make the emitter base junction forward bias. Similarly, battery VCB makes the collector base junction reverse bias. In this region, the transistor is used for amplification. In this region, the collector current depends upon the base current. So that is the active region. Now, case 2 is our saturation region. So in this saturation region, if I draw the circuit diagram, so here the emitter base junction is in forward bias and the collector base junction is in also forward bias. So this is plus, this is minus, VEB. This is plus, this is minus, VCB. This is the emitter. This is the collector. And this is the base. Okay, so here in this region, both the junctions are in forward bias. The transistor works in saturation. In this region, the collector current becomes independent of the base current. Therefore, the transistor acts as a closed switch. So here we can use it as amplifier. Here it can be used as a closed switch or switch. Now, case 3, that is cutoff region. So for this cutoff region, if I draw the circuit diagram, this is our, for the cutoff region, if you see, the emitter base junction is in reverse bias and the collector base junction also in the reverse bias. So I connected it in the reverse bias. I connected this also in the reverse bias. So this is minus plus, this is VEB, and this is minus plus. So this is also VCB. So this is E, this is C, this is B. So there, this is an PN transistor. So in this region, in this mode, both the junctions are in reverse biased. The transistor has practically zero current because the emitter does not emit charge carriers into the base and no charge carriers are collected by the collector except a few thermally generated minority carriers. The transistor is open in the mode when it is used as an open switch. So this is a closed switch, this is a open switch. This is for the cutoff region. And the last case, that is case number 4.
सर ओपन स्विच वाला फिर से एक बार बताइए ना कट ऑफ रीजन का.
Okay. In this mode, both the junctions are in reverse biased in this region. The transistor has practically zero current because the emitter does not emit charges carriers into the base and no charge carriers are collected by the collector except a few thermally generated minority carriers. So if there is no conduction, that means it is an open circuit is open, the transistor is an open. So in this open mode, it is used as an open switch. Number case 4 is the inverted region. It is the inverted inverted region. So in this inverted region, if I draw the circuit diagram, same it will be a transistor. So this is NPN transistor. So in this case, the emitter base is in reverse bias condition. So I will connect the battery in reverse bias, and the collector base is in forward bias condition. So this is forward biased. So this is minus, this is plus, this is plus, this is minus. So this is VEB and this is VCB. Okay, so this is here, this is emitter, this is the base, sorry, this is the collector, and this is the base. So here you will see in this condition the emitter base junction is reverse biased and the collector base junction is forward biased. Since the doping level of the emitter and the collector is not the same, therefore the collector cannot inject the majority carriers, charge carriers into the base. So that's why in this region the action of the transistor is very poor. So the region does not have any working function, or it does not have any applications in this region. So it is just for another region which is named inverted. Because inverted, why? Because if it is active mode, then the emitter is forward and the collector is in reverse. But here the emitter is in reverse and the collector is forward. That's why it is called the inverted mode or inverted region. So these are the basic transistor biasing that when the DC current is applied to the bias, DC current is applied to the emitter base connection and the collector base connection, these will happen. And these are the different modes of operations of the transistor. It is a generalized way. So hope you will understand, and I will going to the next part of the class. Now we have to explain the working principle of a transistor. So what are happening in the inside the transistor? If I open the transistor and using the biasing effect, if we do the biasing and then we open the transistor, then what is happening in this transistor, how the current is flowing, where the electrons are flowing, what is happening, and all the things that will be known as the working of a transistor.
सर
हाँ बोलो.
सर जो आप एक्टिव रीजन समझाए वो एमपीएन था या पीएनपी?
हमने सब एनपीएन रीजन लेकर किया है, एनपीएन ट्रांजिस्टर.
सर जब एनपीएन है सर, जब एनपीएन को हम एमीटर को फॉरवर्ड करें, एमीटर बेस को फॉरवर्ड रीजन में करेंगे तो एमीटर को पॉजिटिव टर्मिनल के साथ जोड़ेंगे या नेगेटिव टर्मिनल के साथ?
मैं फॉरवर्ड बायस बोल रहा हूँ. अगर एनपीएन ट्रांजिस्टर हो तो एनपीएन को नेगेटिव टर्मिनल के साथ जुड़ा जाएगा. अगर
फॉरवर्ड बायस को नेगेटिव टर्मिनल के साथ जुड़ा जाएगा.
हाँ वही तो मैंने बोला
सर. वहां आप पॉजिटिव लिख दिए हैं सर.
ना, मैंने पॉजिटिव लिखा इसी कारण की फॉरवर्ड बायस कौन सा है और रिवर्स बायस कौन सा है, इसे दिखाने के लिए, और कुछ नहीं. वरना तो सभी जगह पे पॉजिटिव नेगेटिव लिखना पड़ता है, सिर्फ सिंबल चेंज होता है. जैसे कि मैंने यहाँ पर लिखा है ये सिंबल जस्ट चेंज होता, दिखाता हूं मैं आपको। ऐसा ऐसा लिखना पड़ता मुझे, ये पॉजिटिव नेगेटिव लिखा तो ये भी मैं लिखता पॉजिटिव नेगेटिव, ये पॉजिटिव नेगेटिव नेगेटिव पॉजिटिव लिखा तो ये भी मैं लिखता नेगेटिव पॉजिटिव। ओके, यहाँ पर पॉजिटिव नेगेटिव लिखा तो यहाँ पर भी हमने पॉजिटिव नेगेटिव। ये क्या है, कट ऑफ ना, ये सॉरी 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 सॉरी, दिस इज पॉजिटिव नेगेटिव, 1 minute, I'm writing, I'm changing the color so you can understand this point. Okay, this is positive, this is negative. If I write this, then this will be written as positive and negative. So if I write here for the saturation, this is negative, this is positive, so this will be also negative and positive. So here also, for the time of
Sir?
cutoff, for 1 minute, just let me finish. For the cutoff region, if I write positive here, negative, so this will be written as positive as well as negative, because it is NPN transistor. And here also, if I write here positive, here I write negative, so this here also will be written as negative and positive. Okay, now it is okay.
सर हेलो
बोलो।
सर, एक्टिव रीजन में जैसे एमीटर का पॉजिटिव टर्मिनल दिखाए हैं,
एक्टिव रीजन में एमीटर में बैटरी
नेगेटिव होना चाहिए सर।
हाँ, तो नेगेटिव ही हुआ है, इसमें फॉरवर्ड बायस मैंने किया है। एमीटर के लिए नेगेटिव टर्मिनल ही एनपीएन ट्रांजिस्टर के लिए वही पॉजिटिव है। अगर फॉरवर्ड बायस बोलते हैं तो एनपीएन ट्रांजिस्टर के लिए मेरा नेगेटिव पार्ट ही फॉरवर्ड बायस है, ये नेगेटिव पार्ट होता है। और पीएनपी अगर होता तो मेरा वो हो जाता आपका ऊपर बड़ा होता, नीचे छोटा होता, ये डिफरेंशिएशन हो जाता है। एनपीएल के लिए ये बैटरी का जो सिंबल है वो देखिए, बैटरी का नेगेटिव छोटा होता है नेगेटिव सिंबल, बड़ा होता है पॉजिटिव सिंबल। तो नेगेटिव यहाँ पर कनेक्शन किया, इसीलिए मैं फॉरवर्ड बायस कर रहा हूँ, पॉजिटिव नेगेटिव यहाँ कर रहा हूँ एज रेस्पेक्ट टू एनपीएन। अगर पीएनपी हो जाता तो कनेक्शन अलग हो जाता। अंडरस्टैंड व्हाट आई एम टेलिंग?
यस सर।
अगर पीएनपी हो जाता तो पूरा कनेक्शन चेंज हो जाता, पर मैं सब कुछ एनपीएन ट्रांजिस्टर लेकर कर रहा हूं। मैं ऑल द थिंग्स दैट वी आर टेलिंग इज बाय एनपीएन ट्रांजिस्टर। सो एनपीएन ट्रांजिस्टर के एमीटर पे हर वक्त मुझे नेगेटिव देना पड़ेगा और हर वक्त मुझे एमीटर बेस में हर वक्त मुझे पॉजिटिव देना पड़ेगा। तो वही मैंने किया, पॉजिटिव दिया, यहाँ पर नेगेटिव दिया। जब सैचुरेशन आ रहा है तो दोनों ही फॉरवर्ड बायस है, तो देखो दोनों ही नेगेटिव मैंने कनेक्शन किया, यहाँ पर भी नेगेटिव, यहाँ पर भी नेगेटिव। ओके, तुम्हारे जो प्रॉब्लम हो रहा है यहाँ पर, तो मुझे ये सिंबल चेंज करना पड़ता था, ये सिंबल। एक मिनट मैं कर देता हूं, मैं कर देता हूं। आपका जो आपका प्रॉब्लम हो रहा है मैं समझ रहा हूं, उसे सॉल्व करने के लिए ये करना पड़ेगा। यहाँ पर मुझे नेगेटिव देना पड़ेगा, यहाँ पर मुझे पॉजिटिव देना पड़ेगा। ओके, अब तुम्हारे लिए आसान होगा।
यस सर।
अब यहाँ पर पॉजिटिव देना पड़ेगा, यहाँ पर नेगेटिव देना पड़ेगा। ठीक है, आप देखो यहाँ पर मैंने नेगेटिव दिया, यहाँ पर पॉजिटिव दिया, This is for saturation, and this here it is saturation में आपका forward biased है, this one, and this is also in forward biased. So this is negative, this is positive. Okay. So cutoff region में क्या है? Cutoff region में this is reverse bias. So this is positive, this is negative, and this is also in reverse bias. So this is positive, this is negative. Okay. Now here in the inverter, this is positive, this is negative, it is okay, and this is negative, this is positive. Now it is okay.
Yes, sir. वो ठीक है.
Next, we are going to the working principle of a transistor. Working of a transistor. So if I draw the circuit diagram of a transistor, internal, then just allow me some time to draw the diagram. Just wait a minute. Okay, so little bit like this. let us draw it now, the respective rest part. This is the battery connections. Okay. This is the base connections. Okay, this is another battery connection. This is the negative, this is the positive. There are three parts. One is so this is N, this is P, this is N. So this is the electrons flowing this side. These are the electrons. These are also electrons. Electrons are there. Electrons are there. Here there is a recombination with holes. Collector collects the current. Okay. So this is VEB. So the current is flowing in this direction. The current is flowing this direction. IE, emitter current. And the collector is flowing this direction, collector current, IC. Okay. And the base current is flowing this direction, IB. This is the emitter terminal. This is the collector terminal. And this is the base terminal. E, C, and B. This is the VCV. This is minus, this is plus. So the flow of electrons, is in this side. This is the flow of electrons. For the base level, the flow of electrons will be this side. This is the flow of electrons here in the collector terminal. This is denoted by electrons. And this is denoted by holes. So to understand the working of a transistor, we consider a NPN transistor which is biased for active operation. That means emitter bias junction is forward bias by the battery VEB, and the collector bias junction is reverse biased by the battery VCB. The forward bias voltage is small and the reverse bias voltage VCB is quite large. The forward bias on the emitter base junction pushes a large number of free electrons in the n-type emitter. You can see here. You can see here I am talking about this. So you can see this is the case. So the forward bias on the emitter base junction pushes a large number of free electrons in the n-type emitter towards the base. So it is going towards the base. Okay. This makes the emitter current IE. So this makes the emitter current IE. Very few holes also pass from the base region to the emitter region. A very few holes also pass from the base region to the emitter region. This flow of electrons and holes constitute emitter current. So emitter current is a flow of it constitute of flow of electrons and holes. Since the electron current is useful in the action of transistor, it is made larger and larger than the hole current by doping the base region more lightly than the emitter region. Hence, only a very low portion or small portion, nearly 0.5 percentage of the emitter current is due to the holes passing from the base to the emitter. The direction of the conventional current is always taken opposite to the flow of electrons. So after reaching the base region, the electrons tends to recombine with the holes. So we see here, this is the recombination. It is tending to recombine with the holes. But since the base is very thin and lightly doped, only a few electrons combine with the holes to constitute the base current. So this is the base current. The remaining electron passes on the collector, which is positively biased N region. So this is positively biased N region. These electrons are collected by the collector to constitute the collector current. There is another component of collector current due to thermally generated magnetic carriers. So what is thermally generated magnetic carriers for this case? Holes. Holes are the thermally generated magnetic carriers. So holes are the thermally generated magnetic carriers which passes towards the base. This small current component is called reverse saturation current. So this small current component is called reverse saturation current. So this is the working of a transistor. So mathematically I can write IE, that is current, equals to IC plus IB. The emitter current of the transistor consists of two components. They are base current and the collector current. But the base current is only about 2% of the emitter current, whereas collector current is about 98% of the emitter current. Therefore, I can write IE equals to IC, as because IB equals to 0. Because what? 98% of emitter current is from collector. And only 2% of the emitter current is from the base. From the Okay, so that is the working principle or working of a transistor. Hope everybody has understand. Now transistor configurations. Now we will discuss about transistor configurations. So the transistor may be represented as a two-port network. A transistor has three terminals. Any of these three terminals can be made common to input and output. This common terminal is generally grounded or connected to the chassis. Hence, depending upon the common terminal, there are three transistor circuit configuration namely common base configuration, common emitter configuration, and common collector configuration. One thing should be noted that all these three configuration, the transistor works in the active region. This means the emitter base junction is always forward bias and the collector base junction is always at the reverse bias. So let us draw the circuit diagram of three combinations. So this is our NPN transistor. If I draw it by block diagram, so this is N, this is P, this is N. So NPN transistor is our this. So this is our minus plus emitter. This is V0 output. This is our input, BI. In symbol, if you draw it by symbol, so this is minus plus PI. This is E. This is B. This is also common. This is C. And this is B. And this is V0. So this is common base. In common base configuration, the base of the transistor is made common. The input is applied between the emitter base and the output is taken from collector and base. That is the common base. So this is number one. Number two is Okay, this is NPN transistor. These are the three terminals. So this is here. Now I connected a battery here. This is here. It's connected. This is emitter. This is input. This is base. This is output. This is input. This is a load resistance connected with it. If I draw the configuration using symbol, this is plus, this is minus, this is base, this is emitter, this is collector, this is emitter. So this is V0 output. This is plus, this is minus, this is RL. ওটা দিলে? Just a minute. Okay, so this is like this. This is the input Vi. This is represented as input. Okay. So this is the common emitter configuration. Common emitter configuration. So this is common base configuration. This is common emitter configuration. These are the two configuration that we are discussing on. Another configuration, that is number 3, that is our common collector configuration. So let us draw that circuit. This circuit must be learned by heart by everybody. Every time you have to draw these circuits. So this is N, this is P, this is N. So from here, we will take here, this is E. Now I will write this is plus, this is minus, this is base. This is emitter, this is collector. Okay. This is input. This is Vi. Again, a load resistance is connected. This is VG output. So the configuration, okay. So this is the base component. This is the emitter component. This is the input Vi. This is plus minus input. This is the collector. This is, sorry, this is the emitter. And this is the collector. This is also collector, sorry. This is emitter. This is base and this is collector. And here it is emitter base collector. And here it is emitter base collector. This is collector, base, and emitter. This configuration is called common collector configuration. So this is the 3 transistor configuration that we will use in the active region, or when we will use the transistor as an amplifier, we will use these 3 configuration. One is called common base configuration, another is called common emitter configuration, and the last one is called common collector configuration. In common emitter configuration, the emitter of the transistor is made common. The input is applied between the base and emitter, and the output is taken between collector and input. This configuration is mostly used, that is common emitter configuration. Common collector configuration, in common collector configuration, the collector is made common. The input is applied between the base and the collector, and the output is taken between emitter and collector. So that is for the different types of what means configurations.
सर
Hmm.
कॉमन कलेक्टर कॉन्फ़िगरेशन में एमीटर को पॉजिटिव टर्मिनल के साथ जोड़ा जाएगा या नेगेटिव टर्मिनल के साथ?
कॉन्फ़िगरेशन के बारे में अभी बताएंगे, आपके पास डिटेल्स में बताएंगे अभी, ठीक है. So let us start with the common base configuration in details. We will discuss every configurations, and we will start with our common base configurations. So let us start with common base configuration. Just a second. Okay, so common base configuration. Let us talk about common base configuration. So let us do the circuit diagram of common base configuration. Actually, let us see it because it will be more prominent for you if you see the common base configuration. Not a common. So if you want to see, let me share it. Just a minute. Just a minute. I think everybody can see the total configuration. So if I little bit zoom it, you will see this is the common base connection. If you see, you will see that this is the common base connection. And in this common base connection, if I want to see you, so this is the NPN transistor configuration and this is the PNP transistor configuration. So your question was one time that one was telling that there is a question, and that question was what is the connection? So you see here for NPN transistor we are using what? Negative bias is given to the emitter terminal, means negative portion. This is forward bias, but negative is given here. Whereas in the output, that is collector, it is reverse bias, that means positive is connected. Okay. Clear? For the PNP transistor, you see the same reverse case. So you see this thing, it is very important. So if you see this, it will be very important for you. You can see it. So this is, you can see here, This is for the PNP and this is for the NPN. So there is the difference. In this configuration, if I take this common base configuration, emitter current is the input current and the collector current is the output current. The current gain of a transistor is defined as the ratio of the transistor output current to the input current. So what is current gain? Sorry, just a minute. So I told you for current gain, what we can write, current gain is nothing but it is the ratio between the output ratio of the transistor output current to the input current. So what is the output current? Transistor output current. The output current is IC and the input current is IE. So it is nothing but IC by IE. So I can write IC by IE. Okay. So I'm just stop sharing this picture. Opening the whiteboard. And I am writing that current gain may be of two types. One is called DC current gain and AC current gain, depending upon the whether the input and the output currents are DC current or AC current. So for common base, for CV configuration, if I write DC current gain, DC current gain so DC current gain can be written as IC by IE. IC by IE. And that is represented by alpha, where alpha is called the current amplification factor. There are three current amplification factors. For CV configuration, alpha is the current amplification factor. For CE configuration, beta is the current amplification factor. And for CC configuration, gamma is the current amplification factor. We know the value of the collector current is always less than the value of the emitter current. So hence the DC current gain in CV configuration is always less than infinity. So it is alpha is less than 1 in CV. Okay. So from here we can write IC by IE equals to alpha, or we can write alpha equals to, or we can write IC equals to alpha into IE. Same as for C configuration, beta equals to IC by IB, because for the configuration it is the input current is current gain is what I told you, the ratio of input current ratio of output current to the input current. So for current emitter configuration, beta equals to IC by IB. So, and for current emitter configuration, gamma equals to what? Anybody? Anybody? If for CB configuration, IC by IE is equal to alpha, and for CE configuration, beta equals to IC by IB. So what will be the gamma?
1.
Means what is the configuration? Yes, what is the configuration?
I by IB.
Yes.
IC by IB.
ICIB तो आपका वो एमिटर पे हो गया.
Sir, IE
Sir,
by IB.
IE by IB.
Yes. You are right. IE by IE. That is gamma. Okay. So there is a relation between alpha, beta, and gamma. And that relation must be very important. This relation is very much important. There is a relation between alpha, beta, gamma. And that relation, we have to calculate the relation, or we have to find out the relation. So what we have got, I'm going to the next page. Relation of alpha, beta, and gamma. Now look, beta equals to IC by IB. You can write, where alpha equals to IC by IE. Now from the transistor current equation, transistor current equation, we can write I equals to IB plus IC. So I can write IB equals to IE minus of IC. We can write it, no problem. So beta, if I take IC, no change, but IB is been substitute. Let us use this equation number 1. So I can write here IE by IC from equation 1.
Yes, sir.
No problem. Now I divide it, both sides, means numerator and denominator, by IE. So dividing by IE, you write here IC by IE by IE by IE minus IC by IE. So writing dividing by IE so IC by IE is what? And let us name this equation
Alpha.
number. Yes. So this is alpha. And IE by IE, so it is cut it. So I
1.
can write here 1 minus again IC by IE, that is equals to alpha. So from equation 2, so I get the relation beta is equal to alpha by 1 minus alpha. So this is the current amplification relation of current what I told, current amplification factor relation between the common base current amplification factor with the common emitter current amplification factor. So hence the current gain in common emitter is very high. From the above equation, it is very evident that alpha approaches 1. If alpha approaches 1, beta reaches infinity. So hence the current gain in the common emitter connection is very high. This is the reason this circuit connection is mostly used in all transistor applications. Okay.
Okay, sir.
Now, if I see for the collector current, if I go for the, what is the time? Just a minute.
Sir, did you eat, sir?
Yes.
Oh,
So if I write this, mm, with the emitter current for the collector, if I think about the collector portion, collector current. So if I show the collector portion, along with the emitter current flowing, there is some amount of base current which flows through the base terminal due to electrophore recombination. As collector base junction is reverse biased, there is another current which is flown due to magnetic charge carriers, and this is called the leakage current, which can be understood as I leakage. This is due to the minority charge carriers and hence very small. The emitter current that reaches the collector terminal can be written as alpha into IE, because I saw IC equals to alpha into IE. But total collector current, that is IC, can be written not only alpha into IE plus also I leakage. That is due to the minority carriers. If the emitter base voltage VEB, equals to 0, even then there falls a very small leakage current which can be termed as ICBO, because it is the base emitter current collected to base current with output open. So I can write IC equals to alpha into IE, that is the emitter current that is coming to the collector, plus ICBO, that is the leakage current. So from our transistor current configuration, I know I equals to IC plus IB. So if I substitute this equation with this equation, then what can I write? IC equals to, that means IE value has been substituted here. So alpha into IC plus IB in plus ICBO. So that can be written as IC into 1 minus alpha equals to alpha into IB plus ICB. Or IC can be written as alpha into 1 minus alpha into IB plus ICBO by 1 minus alpha. So IC can be written as alpha into 1 minus alpha into IB plus 1 by 1 minus alpha into ICB. Hence, the above derived is the expression for collector current. The value of collector current depends on the base current and leakage current, along with the current amplification factor of that transistor is in use. Okay.
Yes, sir.
Yes, sir.
So if the base circuit is open, that is IB equals to 0. So if the base circuit is open, base circuit is open, that means IB equals to 0, then this equation ICEO, why ICEO? Because common emitter open configuration equals to 1 by 1 minus alpha into ICB. So if I use this equation, if I use this value into the previous equation, then what I will get? I will get IC equals to alpha into 1 minus alpha into IB plus ICEO. Because what? This is what? This is equals to ICEO. So that can be represented as beta into IB plus ICEO. Understand?
Yes, sir.
Okay, so up to this today, no more. Next day we will discuss about the gamma and beta alpha relation. We will discuss about that. So up to this, if anybody has any problem, you can ask me, because I think today I will not start it again. So जितना देर आज तक पढ़ाया हूँ, अगर किसी को कहीं पर भी अगर कुछ है प्रश्न तो बता सकते हो. अगर आज कुछ नहीं तुम लोगों को सूझ रहा है तो जब ये वीडियो देखोगे या नोट देखोगे और बुक्स पढ़ोगे तो कहीं पर भी कंफ्यूजन हो तो आप टेचमेंट पे आपका सवाल दे सकते हैं या मुझे व्हाट्सएप कर सकते हैं, मेरा नंबर दिया हुआ है. फिर भी अगर कुछ प्रॉब्लम हो तो नेक्स्ट जो क्लास है नेक्स्ट डे हम लोग, फिर से बोल रहा हूं, आपका रूटीन में जो भी क्लास शेड्यूल है, मेरा क्लास शेड्यूल है मंडे फ्रॉम 12 PM to 1:40 PM and Wednesday from I think 10:20 to 12 PM. So that is my schedule. It is given in the teachment also. So please don't take any misguidance or misunderstand. That is the institutional routine that is published in your groups. Lateral, I am asking for the lateral mainly I am telling this to lateral. So that is institutional routine. But unfortunately, Amrita madam has resigned from the college. So at that reason, I am taking the basic electronics class, but I have a busy schedule because I take other classes also. My regular loads are others because that class was for Amrita madam. So she is not there. So I have to take the basic now for the betterment of you. So that's why I have to arrange my own schedule with the old schedule. So I don't disturb the Wednesday schedule classes. I already disturbed that schedule class of another day. I think on Thursday or Friday there is a Amrita madam's class that has been rescheduled to Monday this odd time, that is 12 to 1:40, because I have a busy schedule. I cannot arrange any two classes. So it is permissible from the department as well as the institute, but it is not focused in the routine as because there is no schedule time from 12 to 1:40. This is a rescheduled time. So I request you to join on this particular schedule of me for basic electronics classes. That is Monday from 12 से 41 के बीच में और वेडनेसडे 10:20 से 12 तक. आई थिंक 10:20 से 12 तक वही है. सो मुझे नहीं लगता फिर से कंफ्यूज होगा. अगर किसी को और कंफ्यूज है तो मैं चाहूंगा कि आप लोग जितना भी आज कॉलेज में क्लास में प्रेजेंट है आप लोग बता दीजिए कि ये कंफ्यूजन नहीं होना चाहिए. So thank you again. I am ending the class. Thank you very much.